Hello, chemistry students. In this video, we'll continue the series of stoichiometry calculations, and we'll figure out how to determine how much excess reactant is left over. So you have already watched stoichiometry, both limiting reactant videos and percent yield videos. And in both those videos, we talked about the theoretical yield, and we also talked about which one is a limiting reactant and which one is an excess reactant or a reactant in excess. So now we're going to calculate, well, how much excess is left over? So these problems are very similar. I took the same problems from those videos, but now I'm applying it slightly different. So how much excess reactant remains if you begin with 0.552 moles of aluminum and 0.887 moles of chlorine? So right off the bat, they give you two quantities, right, for two reactants. This is like a limiting reactant problem. In fact, we have to figure out which one's limiting reactant and which one's excess. And the only way to do that is to do what we've been doing all along, the double stoich. So we set up our double stoich just like we did previously, and we realize that the smaller amount is our theoretical yield, right? This is the theoretical yield, what we get on paper, the smaller amount. And the limiting reactant is what gets used up first. But what we want to figure out is how much excess remains. So we know right off the bat, we start with 0.887 moles of chlorine. And we know this is the excess because the limiting is aluminum, and that was determined by the theoretical yield. So how do we figure out, of this 0.887 moles of chlorine, how much gets used up and how much remains? Well, we have to figure out how much is used in the reaction in the production of this theoretical yield, and then we'll subtract how much is used from how much we begin with to figure out how much remains. And that's basically what you're doing. So how do we do that? Well, we take the theoretical yield and we say, okay, well, I know I have to produce 0.552 moles of the aluminum chloride. But I want to know how much of the excess reactant of chlorine there is. So I do a mole ratio, right? I go to my balance equation and I say, oh, well, there's 2 moles of aluminum chlorine per 3 moles of chlorine. Basically, I'm taking my theoretical yield and I'm working, oops, sorry about that. I'm working back to the excess reactant. That's basically all I'm doing. So I get a value. When I calculate this out, I get 0.828 moles of chlorine react. Okay, so that's how much gets used up. So now I put that over here, 0.828 moles of chlorine get used. To figure out how much remains, I do my subtraction. So 0.059 moles of chlorine remain. And that would be my final answer. And yes, this is 3 sig figs, and this is only 2. But remember, we're following the rules of addition and subtraction, and we go to the precision of that measurement, which is to the thousandth place. So 59 thousandths is the correct answer, and that would be my final answer. But just like we said, not do we only do mole to mole calculations with stoichiometry and gravimetric stoich, we can also do gram to gram. So in a previous problem, we did something similar to this. We were asked to determine the limiting reactant and the theoretical yield. Well, now it's saying, well, what amount of reactant remains when 45.8 grams of nitrogen monoxide and 12.4 grams of hydrogen react? Now, if they tell you this, just pick a product to do your double stoich and work towards that product to figure out which one's the limiting reactant. And once you figure out the limiting reactant and the theoretical yield, you can work back. So I just took the prior problem that we worked on in the video where we converted both reactants, the nitrogen monoxide and the hydrogen, all the way to grams of ammonia. And we picked, what did we pick for theoretical yield? The smaller amount. So in this particular problem that we did in the prior video, we see that the nitrogen monoxide is a limiting reactant, and that means my excess is hydrogen. So how, oops, I spelled excess wrong. How do I figure out how much hydrogen remains? It's the same thing. I'm going to take that 12.4 grams of hydrogen that I start with, and I'm going to subtract how much reacts to produce this theoretical yield. So basically, I'm going from the 26 grams of ammonia to the grams of hydrogen, just like I said before, to the grams of the excess. So I have 26.0 grams of ammonia, and I need to convert grams of ammonia to moles of ammonia. And how do I do that? Well, 1 mole of ammonia, and it even says right here, is 17.04 grams. So grams of ammonia cancel. I want to know how much excess hydrogen. So now I need to go from moles of ammonia to moles of hydrogen. And how do I do that? Well, there's 2 moles of ammonia per 5 moles of hydrogen. So now my unit of moles of ammonia cancel. And the last step is I want to know how many grams of hydrogen reacted to produce this theoretical yield. So I go from moles of hydrogen to grams of hydrogen. And how do I do that? Again, molar mass, 1 mole of hydrogen, and I even have that in the prior problem, 2.02 grams. And I end up getting a value of, let's see, 7.71 grams of hydrogen react to produce that theoretical yield. So what do? I have to say, and I'll make it a little bigger, 12.4 grams of hydrogen is what I start with. I want to subtract 7.71 grams of hydrogen that's required to react. And I end up getting, what do I end up getting? I end up getting 4.69 grams of hydrogen remain. But remember, I have to follow my rules of sig fig. So I go here to the tenths. So my font, because 12.4 is to the tenths, even though 7.71 is to the hundredths, and that has 3 sig figs because this does. But in addition to subtraction, I follow that rule. My final answer is 4.7 grams of hydrogen remain. So in both these problems, we see that what do we have to do? We have to do the double stoich, determine the limiting reactant, and determine the theoretical yield. And only then can we figure out the amount of excess that remains. Now, this isn't a lot, so we're going to do one more to make sure we got it. So when 11.5 grams of carbon are allowed to react with 114.5 grams of copper 1 oxide, how much excess reactant remains? So again, we would just pick a reactant, and you could go to moles. I'm just going to do it this way because I have you going all the way to grams in the prior video, so I'm just going to be consistent. But this is from the prior video. We did the double stoich with both the 11.5 grams of the carbon reactant and 114.5 grams of the copper 1 oxide reactant. We converted it all the way to grams of copper. we picked the smaller amount, the 101.7 grams is less than 122, and said this is my theoretical yield. And this must be my limiting reactant, so carbon must be my excess. So now in this problem, we're not done because we want to know how much excess remains. So again, what am I doing? I'm going from my theoretical yield all the way back to the excess. So how do I start this? I start with 101.7 grams of copper, and I convert that to moles. So how many grams of copper per mole of copper? Well, I look at the periodic table, and 1 mole, there's 63.55 grams, and I'm just using these. And now I go from moles of copper, right? Because that's where my theoretical yield is, to the moles of my excess reactant, to moles of carbon. And where do I get that? Well, there's 2 moles of copper per 1 mole of carbon. And then I go from moles of carbon to the grams of carbon required to react to produce this theoretical yield. 1 mole of carbon, I look at the periodic table, 12.01 grams of carbon. What do I get? I end up getting, because I got to follow sig fig rules, 9.610 grams of carbon react. Now, what do I do to figure out how much remains? I don't want to just know how much reacts. I want to know how much remains. I'm going to subtract that from the original 11.5 grams of copper or of carbon that I started with. And when I subtract that, I end up getting, what do I end up getting here? Oh, 1.890 grams of carbon remain. But I have to follow my rules of sig figs, and I see that the 11.5 only goes to the tenths, so my final answer can only go to the tenths. I look over, I see there's a 9, I round up, so 1.9 grams of carbon remain in excess. So again, to figure out the amount of excess reactant, you have to do the double stoich to determine the limiting reactant and the theoretical yield. Once you know which one's the theoretical yield and the limiting reactant, you take that theoretical yield and work back towards the excess reactant to see how much was required to produce that and subtract it from your original amount. So I hope these 3 examples help. If anything, you've seen a lot of stoichiometry forwards and backwards, and it gives you enough practice to succeed on your homework problems. So if you have any questions, go ahead and leave them, and thanks for tuning in.